as I pull up everything for today, now might be a good time to ask questions about any of the topics we just discussed. No questions, okay. So I'm loading in.
One thing I would say is that SMS is continually adding a lot of new features. So they're making it easier and easier for the users to pull in coastlines from different databases. So eventually there'll be a toolbox that you'll be able to select different resolution coastlines and then automatically get it for the area that you're inside of. So hopefully that's coming in 13.4, as well as being able to go out there and get other bathymetry, say from JEPCO or some other different bathymetric databases, things like that. So they're always adding new stuff. And so we try to integrate those options back into these presentations, but sometimes we are a little bit behind. But just play around when you get a new version of SMS and see what new features are. Maybe go to their website and they'll have some different documentation for the new features that have been added.
Thank you, Mitch. Okay, I pulled all of our data in, and I'm not going to remove these, but I am going to deselect them, our old scatter sets that are the components of our merge scatter sets. Okay. And next thing we're going to do is change the display options. Oops. So display options, we want to turn our inactive coverage on. This is interesting. So again, things are changing all the time. Oh, scatter. Okay, go to map. And now we can turn on our inactive coverage. And that looks like we would expect it to. Great. Okay. So next we will build a few map data types. So we'll go to map, new coverage. We want a boundary condition. So that will be model type. We didn't get this today, but we will cover this tomorrow. So you can see for CMS flow, we have rubble mound jetties, boundary conditions, and save points. So those are all CMS specific, CMS flow specific coverages. So we have boundary conditions, activity classification, and quad tree generator. I think that's it. Okay, so we'll zoom in on the area that we care about and start with, I'm going to start with the quad tree generator. Just getting a sense of about, did that click? Okay. And so you can kind of see our grid frame, but what we can do is our scatter contours are what is being visualized. So we'll go to the contours and change the transparency. I'll set that to 30. Okay, much better. So now we can select on this grid frame, play around with that. We can rotate it. We can limit the onshore area that we care less about and maybe extend to a little deeper waters. We can look, I'm going to jump ahead and add some imagery. So this is a pretty sometimes that takes a minute to load, but this is a pretty urban area. You can see it's still processing. There it is. But if, for example, if we were somewhere with a lot of inlets, we may be more careful about the longshore bounds of our model to make sure we're including the connectivity between waterways that actually influence the inland processes that we're more concerned with. And in this case, we shouldn't be too sensitive to the choice of model boundaries in the longshore condition or the longshore direction. And because that keeps my computer working really hard, I'm just going to turn off that imagery for now. But we can come back to that if we'd like. Okay, moving through our documentation and guidance. We can see, again, if we right click here and look at the properties, these are all the items that we were just discussing with our cell sizes, maximum cell size out here, but we'll leave that until we play with the geometry of the quadrigrid generator a little bit more. Okay, so now we're going to be working on the activity classification. So we'll switch to that mode. We can still see the bounds of our quadrigrid generator grid frame. So we have nothing here. We can, we were doing something for a very quick test case. We could just do something like this and create a contour. Excuse me, not a contour. This is just an arc. Being very arbitrary about the elevations that I'm choosing to define those points. So what I can do, this is the select objects of all type. So sometimes this is useful if, for example, you want to do that, play with a node, delete a vertex. You can do that all with just this selector. But sometimes it's more helpful to have a specific tool selected. We can add a vertex. Oops, that's the select. That's the generate. And again, just play around with that. So that's the quick and lazy way to do things. The other way that we discussed and is what you'll want to do when you're doing this for important research questions. You can go to scatter, make sure you are selecting the scatter data set that you care about, this merged all, and convert scatter to map, scatter contour to map. And let's just say we estimate that there might be as much as 1.5 meters total tidal range in this area, which seems high, but just to be safe, we'll say a 2-meter contour and keep the spacing around the contour to be 10 meters. Now, if we hit OK, we look at this and we think, wow, that's really low. It should include at least the areas that are at the 0 water surface level, the 0-meter contour. However, remember that our contour scatter set is set to depths. So that's something to keep in mind. What we can do is do that again, but this time with -2. Okay, that looks better. So now we have higher up on the shoreline as opposed to further down, so that this is a 2 meters of depth contour, 2 meters under mean sea level, whereas this is 2 meters above mean sea level. And we'll use that as our activity classification. So a cool feature that we can use is when we have one thing selected that we want to keep and want to get rid of everything else, we can right click and we should be able to, where is it? Invert selection. Okay, let's see if this works. Oh, Okay, we don't want to merge it all. So what happened? Okay, so remember, this is important to remember. Whatever is bold, whatever is highlighted, that is the active feature in our data tree. So we have to make sure we're in activity classification to delete the features that we care about. So we might want to go back to select arcs, delete that. We can delete some of the other arcs that we were playing around with. We can delete these arcs and so on and so forth. And we can turn where we are now. If we're creating an arc, it's going to snap to an existing vertex. We can pull this out, go across to the area that we roughly care about. Okay. And this is messy. I recommend you cleaning this up, but let's see if we can still feature objects, build polygons. One or more feature arcs was cleaned to prevent the formation of overlapping polygons. Okay, thank you, SMS, for doing that for me. So now we can collect polygons, and now we can play around a little bit. So this polygon, we'll keep that as inactive. This polygon is also inactive. That's great. This polygon is inactive. No polygon here. We can see our water, which has no polygon around it or no arcs around it. It's not clickable, which is fine because if it's not inactive, it's going to be interpreted as active once we get into the modeling space. I think if I delete this polygon, it will delete the polygon feature, but it doesn't delete the line. So unfortunately, there is some cleaning up to do on my end, but we can also skip ahead to the next set of data sets that we have for us to play with this week for the webinar. So you can do this on your own time, playing around with SMS. I'm going to close out of this. Just say, no, don't save it. I don't want to override our starting points, but I'm going to go to after bringing in a coastline. Okay, so we have a nice coastline. We'll move to the activity classification, do this again for a hot second. Okay, feature objects, build polygons. Great, that's there. Let's see that's inactive. I'm going to switch it to active just in case that gets wetted over the simulation. You can also just alternatively delete that polygon. Our quad tree generator is here. We can select it and play with it a little bit. Make sure to get, if we turn on our inactive coverage, then we can see the bounds of our simulation active space. We want to make sure our grid generator is at least inclusive of that. So we've got a quad tree generator. The next thing we talked about is the polygons that we need for the quad tree generator polygon and resolution definition. And what I'm going to do is I'm going to cheat a little bit and bring in the map data from the next set of codes, next sets of files, and it gave me a warning that it was going to read in some boundary condition information, even though we already had a boundary condition map layer. So that's okay. It numbered these as 2, so we know which ones are the ones that were from the next stage of the simulation. So I'm just going to go ahead and delete our old boundary condition. I'm going to keep our activity classification that we just worked on. I'm going to delete the second one that was brought in. With this quad tree generator area property. Okay, I don't see the polygon lines. That must be the next set.
Hey, let's look under the CMS grid creation folders. There's an intermediate step and then there's a final step.
Perfect, thank
You can
you.
grab the data from there.
Okay, so as an intermediate, I'm just going to bring in the simulation. Don't worry about the previous stuff. And now you can see some of these polygons that we were just talking about. So now when we are working in the quad tree generator map property, we can double click these and see that the maximum cell size here was set to 40. And note that the dimensions of these what appear to be unitless are whatever is going to be your default projection. So we're working in meters here. You can see that down along the bottom. So this corresponds to 40 meters. Let's see. In the next one, so down by a factor 2, that's going to be 20 meters. And then again, this might be where the navigation channel is or some deeper features, and we're going to resolve that to be a much smaller size. Let's confirm. Okay, this is even smaller, 5 meters. And that is it. So when we work in now that we have a quad tree generator, grid frame properties, what we want to do is when we're happy with these polygons and what the set resolution is going to be, we right click here on the map data and say convert to quad tree UGrid, which stands for unstructured grid. So unstructured just means non-Cartesian. So that's inclusive of triangular meshes as well. So we can name this to be whatever we want. We can call this the webinar grid. This was taken directly from our grid frame properties. The target minimal cell size is less than 5 meters, which I don't know if we set 2.5 anywhere in our quad tree generator polygons, but that is possible where that was taken from. We can always adjust that. Although this is grayed out. So
That's directly taken from your minimum cell size and that's defined. So it's probably in that little area within the inlet. The small little pond off to the south. It's probably there.
Oh, I see it right here. Yeah, I can't just zoom in now, but we can set the maximum to be, we had 160 in the notes, but let's just try with 200. Probably won't change things too much. Don't forget to define what the depths are going to be before we hit OK. We can say constant. So for example, if you're working in an idealized case, I'm not sure that this would ever be super useful because generally we have some gradients in topography and bathymetry, but we will use the scatter set option. We're going to take the merge data set, and here for extrapolation, if there's areas, for example, if our scatter set was not covering the entire area of the quadri-grid. We can use this extrapolation option, although do be very careful with this. I highly recommend that your scatter set is larger than your gridded area of interest. On the interpolation side, you can choose between linear, natural neighbor, which that might be closest neighbor. I'm not exactly sure. I can't remember. Inverse weighting distance again, but highly recommend linear for most values. You can truncate the values, so define a minimum and a maximum. And if this were an evolving data set, like for something else, you might be able to select a certain period in time to do that, or although that may be for some other functionality. In general, we typically just work from a scatter set to quadri grid. Say okay, make sure it caught that here in the next little dialog, hit okay. Little blue circle indicates that it's thinking and working really hard. Okay, so you can see this is what it looks like when we only define the areas that we only define certain areas for the resolution. You can see it quickly moved from the smallest possible resolution that you defined to the largest resolution that you defined in the minimum number of transients. So that's why in the webinar, and you can look in these other data sets that are provided, a more refined resolution. And I think, yeah, you can bring that information in if you wanted to. Okay, I believe that's everything we worked through today or discussed. Before I stop sharing, I'll ask if anyone has questions. Chat. Show the adjust button. Adjust. Show how to change the transfer. Oh, okay, thank you. Transparency.
No, that's talking about when you were in the map to quadri grid dialog, you entered 200 as the maximum.
Oh, yes, and that's
If
when you hit it.
if you're thinking about it, since the minimum spacing is 2.5 meters, 200 is not a factor of 2.5 meters. So what you can do is you can hit that adjust button and it'll readjust that maximum to be some factor of your minimum. And say if that 320 is too big, then you can manually enter that to be 160. It just tries to get the next size larger than what you enter there.
That's right. Thank you. Okay. Okay, now we have two because the first was our webinar grid, so I'll turn that off. And now you can see. So if we zoom in, our first grid had a maximum size of 320 because that's exactly right. 200 was not a factor of 4 from our last prescribed resolution size. And then we can turn on our other one, which is slightly smaller, but maybe still large. Okay,